Hello, can everyone hear me? Okay, cool. Okay, so last time we made a pizza class, didn't we? So we're going to go over classes a little bit more. One of the things that we need to look at is the self parameter. So one way to think about the self parameter is basically it's kind of a temporary placeholder for what will be the object later on. And it's the thing that's going to hold our data, essentially. Notice that methods, as opposed to regular functions, have the self parameter in all of them. So when you write methods, i.e. functions inside of a class, you're going to be using the self parameter as the first parameter. And so try writing this one, right? Make this class called food expert. And notice that this one has an init method. And so we're going to, there's some things that'd be nice to be able to initialize when we start off the class. So we're going to make an init method that will start off by setting good food equal to an empty list. And this class will have an add good food method. It's kind of like a set in some ways, but notice that whatever you pass in doesn't get set into good food. It just gets appended to good food. And then we have a likes method and a prefers method. So write that, and then we'll talk about this class. Okay, so if you look at this class, what does the likes method do? What's that? Well, yes, there's definition for likes, but what does it tell? What does it kind of describe what it does in general? So it's returning X in self.good food. Seeing if it's there, right? Yeah. So likes is just seeing if I pass in some food item here, it's telling you if it's in what this food expert thinks is good food. What does the prefers do? It takes two parameters and then it's doing stuff with it. It compares them, and then what does it return? It returns the one we like better. So does that make sense to everybody online? Yeah, so it's just a way, basically we're just using a class to kind of, represent, this idea of what someone would prefer in food. And this kind of tells you also that the order you put the food into the list is important in this particular application too. So then, and what's different about this than what we've done before is it has an init method. And so you kind of have to make sure that you always run, when you instantiate a food expert, you always run the init method to begin with, because that initializes the list. If you don't initialize the list, all the other functions will probably fail. And we have an add method, and then we have our, these do they like this or do they prefer something? So so I guess, let's see. It doesn't have examples of running that. So I'll slam it in real quick. Okay, so how would I initialize it? How would I initiate a food expert? food expert. Yeah, the expert one is equal to food expert. That's our instantiation statement, right? And then with this class, what should I do right away? So online, what should I do right away with this class? Well, I could, but what does this class in particular have that we probably should run first? Yeah, we need to run this init method up here. So I'm going to say expert one.init. And of course, if it has a self, I don't need to put anything in here. When we call a method, we don't include self because expert one is going to go in for self. So now if I look at expert one dot good food, you can see that right now it's an empty list. Does that make sense? The init method initialized that good food list. So just start suggesting some food I can put in here. So I'm going to take expert one dot add good food. What should I add? Lobster. Excellent. So we can just keep running this and we'll get hungry. I'll put pizza. And now if I say expert one dot good food, I can see that it's appended that. Could we have just made a list and just kind of appended things? Probably, but this class kind of organizes the behavior. Does it kind of make sense? So it's a way of really the purpose of the class is just kind of define the standard things that we want to do to represent what a food expert is. And so let's see, let's try expert one dot likes, and let's see, does the expert like lutefisk? No, they don't. Let's see if expert one likes steak. Yes, they do. So do you see how that works? And then let's see if expert one prefers of pizza and lobster, which one do they prefer? Lobster, because it came earlier in the list. So does that kind of make sense how that class works? And you know, how you organize your class and how you set it up just depends on what it is you're representing. So it takes a little bit of creativity to kind of make it work. But you can kind of think of, you know, it said, well, the attributes, what attribute do we have in this class? Look for the self-dot things. Good food. That's really the only attribute that's on there, right? And then, because X rating and Y rating, there's no self in front of them, right? Those are just temporary variables used in a function to get a result, but we're not storing them in the class. And then we have really four methods. One's the init method, which is just used to initialize it. And then we have add good food, likes, and prefers. And so if you're thinking of something, trying to build a class the other direction, you'd say, well, what do I want to keep track of? And somewhere in there, that's probably going to end up in a self and probably be initialized in the init method. And then you ask, what do I want to do with this? And then you would write your methods. Does that kind of make sense online? So let's try this one. Let's write this class out in a new file. Class my class, and we will have class var1, class var2. And notice that class var1 and class var2 don't have self in front of them. They're defined at the class level. They're not defined in a method. They're just sitting out there inside the class, but they're not inside a function like everything else you've done so far. And then notice we have get class var1 and get class var2, and those return self.class var1 and self.class var2. So make that class and then run it. And see what happens. And then instantiate an my object and then run my object.get class var1 and see if you get initialized in my class. So what do we get when we run that? Do we get back initialized in my class? So we can see here. So maybe the question is, why don't we need self dot at the class level? And the reason is that within a function, you have to put self dot to refer to something belonging to the class. These variables are actually defined because they're at this tab level. That means that they belong to this class, and so it's implied that that's part of self. Within the function, remember that the functions have their own memory space. And so in order to specify that what you're referring to is something associated with the class, you have to use self dot within your methods and your functions. Does it kind of make sense? It's maybe a little fuzzy, but realize if you define, so we can actually, we don't even need that init method necessarily to initialize things. We can initialize variables right out here at the class level. So that's another way of initializing things inside your class, which is kind of what this is getting at. Does that make sense online? Now try this. Type my object, put dot class var1, which is this class variable here, and then pause for a section. Actually, just put the dot. Just put my object dot and see what's listed there. You should see the two get methods that are class, and then also you should see class var1 and class var2. Do you all see that? The IntelliSense and idle is kind of slow, so you hit the dot and you wait for a few minutes. So go ahead and put in class var1, and then see if it comes back with this string. So yeah, it's just showing you again that you can use this to initialize your variables at the class level. So now let's try this. Let's make this other class. So that's basically initialization. We're also going to find out a better way of initializing. Often we do use an init method, but we put double underscores on the front and the back. You put double underscores on the front and the back of your init method. We're going to see that more next week. You can actually get the init method be called automatically, so you don't have to implicitly call the init method each time. So while this is one way of initializing things, you're going to find we end up using the init method more later on. There's another thing that we can do with classes is, let's say that we have multiple classes and we want to share functionality between them. We can actually specify, we can inherit from a class. So write this code out. We're going to declare a class called filter, and then we're going to declare a class called spam filter. And notice the spam filter has parentheses and the name filter, which is a reference to the other class. This is called inheritance. And what it means is that spam filter gets everything that's defined in filter, and then it's going to add some new stuff. So type that in, and then we'll talk about it. You don't have to write all the comments if you don't want to. Okay, so what's going on here? Spam filter inherits from filter, but let's see what's in filter. In filter, let me see if I can do this. So we have two methods. The init method, which declares a list of blocked items, which is an empty list in filter. And then we have the filter method, which we pass in a sequence. And this is kind of a neat thing you can do in Python. It looks a little bit like SQL if you've ever taken it, but basically what it's saying, we want all the elements in self.blocked, or all the elements in sequence, if the element in sequence is not in self.blocked. So basically what it's going to do is if there's something in blocked that's also in sequence, it'll filter it out. Hence it makes it a filter. And x for x in sequence basically is going to is a for loop, and then it'll loop through and select all the things in here that are not in the other list. So try this. Say f equals filter, initialize the filter, and then say filter 1, 2, 3. And let's try to predict what's going to happen. So if that filter method returns all the things that are in this list, 1, 2, 3, that are not also in self.blocked, what should it return? Is there anything in list 1, 2, 3 that's not in the empty list? No, because the list is empty, right? So what do we expect to get back? Yeah, the 1, 2, 3. Now run it, create a spam filter, initialize your spam filter, and then filter spam, 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 eggs, bacon, and spam. And then try to predict what you're going to get. And what do you get? Eggs and bacon, right? And basically what it did is, with spam filter, the question is, hey, we were able to call a filter method off of spam filter. How did spam filter get the filter method? Well, because spam filter inherits from filter, and because filter has the filter method, spam filter also has a filter method. So with inheritance, if in this class when you define it, when you specify another class inside of this parentheses, it gets a copy of everything that's in that one. Does that make sense? So that's why I say it's inheriting. We're saying that this child class spam filter gets everything that the parent class has, which is filter. So that can be kind of useful. Let's say that you have a situation where you want to develop these, there's 5 classes. They all have some common elements, but then they have a lot of things that are unique. Well, you put the unique things in each of those 5 classes, and then you make a parent class which has the things that are common to all of them. Why would we want to do that? What's that? Flexibility. Yes. Maintainability. There's this principle in programming called dry, don't repeat yourself. So it helps us implement the dry principle, because if we needed to maybe make a little change to thing that's in all of them, we only have to make the change in one place and it affects all of them. And so inheritance is a very powerful thing that we use a lot in programming in order to make things kind of work much more smoothly. Now, one of the neat things is we can actually inherit from multiple classes. So in this case, in this class, go ahead and try to write this one. We have a calculator and we have a talker, and then we have a talking calculator, and notice that it inherits Notice that it inherits from calculator and talker. So talking calculator inherits from calculator, and talker, so talking calculator inherits from both calculator and talker. So this is called multiple inheritance. Not all languages implement this because it's fraught with peril sometimes. It can become ambiguous what you're actually doing, but Python lets you do that. And rather than claculate, I recommend you spell it as calculate. Although the computer probably doesn't care if you call it claculate or calculate. Thanks. Okay, so this class is kind of interesting. One thing that is new maybe here is this eval expression method. So I'm going to run this just to get a window. The eval method basically, you can, like if we said some text is equal to 5 plus 8. Some text is just a string, right? If we do an eval on the string, it'll actually evaluate that string as if it's an expression. So that's what this eval does. So the calculate method, if I create a calculator, just doing the same thing. And I look at calc1 dot, except it's stored in calc1 dot value. Does that make sense? What's going on with that? And then with talk, I could make a talker. See what happens if I say talk1.talk. This is that. Hey, it doesn't have an attribute value, and you notice that it needs an attribute value. So talk1 is kind of hard to make work. I can kind of spoof it by doing this, say value is equal to blah. Oh, shoot. I obliterated my talker. Okay, I do that again, and then I could call this method. Now it has a value, so we could assign it that way. But I'm going to rerun this so it's all cleared out. So I rerun this method, so now we're starting from scratch again. I can make a talking calculator, so I could say talking calculator, oops, sorry, TC is equal to and so now if I hit the dot, notice that TC has a calculate method and a talk method. But TC right here just has pass. So what pass is basically says, hey, I don't want to put anything in here, but we can't just do that, because if we just do that, Python is expecting something to come in after this colon. It needs some stuff. So we have to have pass there if you don't intend anything. Why don't we need to put anything in talking calculator? And why is it that even though we just have pass there, I get both talk and calculate from talking calculator?
You're inheriting the functions from both talk and calculator.
Yeah, so I'm inheriting the functions. And in some ways, this is almost like a composition type thing, right? We could make a whole bunch of classes which had little pieces that we needed. And then when we could make a class that takes all the pieces that we need and combine them together into making something, kind of in a modular way. So that's kind of what's happening here. And so if I say talking calculator dot calculate 5 plus 7 divided by something times square root of 10. Hopefully that calculates. Oh, I don't have math.square root in. So I'll just do this again without the square root. We'll raise it to the 10th power instead. Damn it. So just put some formula in there that actually will work. And then I can say tc.talk. And it seems to be working. If I multiply this by 10 and divide it into 7, it's going to make a very small number. That's why it's 5.0. Does that make sense? So we can make a couple classes and we can combine them with multiple inheritance together to make something composed of other classes. Does that make sense online? And that's kind of what we just did. So we're not going to use those things extensively. I like talking about them a little bit. If we have a more advanced object-oriented programming section on this, we would go into, there's a lot of design patterns and things you can do with that to make your code very elegant and clean. And so if you were to take our other courses like C++1 and then C#, C++2, Java, and those other courses, you'd be able to, that's enough usually for you to say, oh, take the object-oriented programming principles you learned there and apply them in C, in Python, and do some more elaborate things. But this is enough for us to kind of understand so that we can use the language and use some of the functions and libraries out there that will use inheritance in them. So how we use object-oriented programming. Basically, some ways of thinking about it is gather what belongs together. In many ways you're asking the question, who does something more than you're asking what it's doing initially. You say, if I'm doing let's say I was making an application for a warehouse and we're keeping track of things in the warehouse. Well, there could, maybe I could say inventory item would be one class, and it would just store information about one item. And then I could say shelf. That would be something that would have a collection and items that, inventory items that would be stored on that shelf. I could have rooms, because there could be multiple rooms which have a collection of shelves in it. I could have a order, which would be a list of items that, of types of items that are being looked for an order. And then I could have some kind of order processing class that would take an order, look to see if there are items in the inventory and on the shelves, would tag those as being part of an order so that someone wouldn't use it in another one, and then would create a work order for someone to go and grab those items and package them up and send them off. So you can kind of think that way of how am I going to group those? Now, by breaking those into classes, now I have a lot of subparts to this problem, and I can farm those out to multiple programmers. If I didn't break them up like that, you made it all in one big long program, you could see it gets very complex and convoluted quickly. It can help a lot. Not that it won't get complex anyway, but it makes it a little bit, at least has an organizational structure, when you're building your code. So, so keep classes focused. There's something called the single responsibility principle, which means each class should kind of do one thing and one thing only. You could make one class that did all this stuff, but it'd have a ton of things to keep track of. It's probably easier just to write an inventory item class. It just represents what one inventory item does. And then once I have that, then write a shelf that has a list of items, right? So I could make a list, and I could just keep adding inventory items to that list and work with it that way. And then maybe I have a search function which searches to see if there's an item of a particular type on the shelf, and then I could have a reserve method that goes in and marks that object as being reserved for a particular order and just associates an order with it. So I could do things like that. And then keeping it simple. You notice a lot of the methods you've been writing are not super large. And so a lot of what you want to do is it's better to have lots of small functions than it is to have big functions. And the way you can kind of get a sense for this is as you're writing, maybe if you think back to the rock, paper, scissors game, think back to that. Could we have broken that up into smaller functions and smaller units and maybe define it even in classes and then keep those smaller so that the overall, eventually your code just looks like instantiate a round, play round, and then do another, and then the round class basically does, displays, the options, gets user input, and resolves the answers. And then, you just kind of cascades out that way. So one way of thinking of it is write down a description of your program. The nouns in your description are probably potential classes. The verbs are potential methods, and the adjectives are potential attributes or properties. And then allocate the methods and attributes to various classes that make sense. I'm going to say that I never do this. I kind of think through, the problem that way. But it's not a bad way of kind of thinking about when you're trying to break the problem down. Nouns tend to be classes. verbs tend to be your methods, and adjectives or descriptors of things tend to be your self dot fields type of thing. And then use cases are actually kind of useful. That a use case is a list of steps you perform to do something. So, how do we put together, an order to send off to a customer? Well, we get a list of items. If we're thinking physically what you do, you get a list of items. You go to shelf 1 and you walk, you look at the shelf number, you go to that shelf. You go look through the items, you find the one that you want. You put it in the box, then you go to the next shelf and you get the next one, then you get the next one. Then you print out a label with the address on it. And then you bring it to the loading dock and it stays there until it gets loaded up into a truck and then it gets delivered. So if you think about that process, well, okay, if I need to make a tracking mechanism for that, I can build my classes and I make everything and I follow that. So use cases are often used in programmers. I actually worked in a company, or I worked when I was working in the Air Force, we had a company that's working for us that was building some software, and they're very good about, they asked us to describe what we wanted to have done, and we wrote a requirements document, gave it to them. And then they took that and they broke it out into use cases, and then they had us review the use case document. Is this what you do for this step? And we confirmed that. Then what they did is they mocked up a user interface, with what the GUI would look like. And they said, does this look right? And we would say, yeah, that looks about right. And then they would make that use case, and then they would have us test that piece, and then we test that piece. And then they bring the next use case up, and we review that use case. And they just went through this cycle, step by step by step. And you can imagine that each one of those use cases probably had 1 or 2 or 3 classes that were associated with it, and were kind of lined up on the interfaces. And they're able to build this application nice and smoothly. There was like no friction. We just, each week, each Monday, we would go meet with them. Each Friday, we would have the next iteration. And over the weekend, we could review things and come back. So that's kind of the workflow. So you can think of classes really as like a template for code that you might instantiate multiple times. Or you can think of it as a blueprint or a recipe. People have different ways of thinking about it. And one of the challenges when you're looking at object-oriented programming text is they're going to talk in all these nebulous terms. But once you have the ability, once you've written a class or two, it's easier then to understand all this nebulous stuff. They're just trying to provide a framework to understand what you're doing. At the end of the day, what we're really doing is just taking a bunch of methods and grouping them together and saying this is a class. So if you think about it, we started off by writing a bunch of statements and making code that way. Then we took our groups of statements and bundled them together and made functions, right? Then now we're taking bundles of functions and grouping them together to make classes. And then later on, after this, we're going to take bundles of classes, put them together and make libraries. And so, it's just kind of this organization that we're doing. And then, the thing that you realize is once you have a class defined, you can say my object, whatever variable name you want, I just used my object here, is equal to my class, whatever the name of the class is, and you use open and close parentheses to instantiate an object. The instantiation part may be a hard thing to understand at this point, but realize what that's doing conceptually is it's saying, hey, use this template of this class and make an object that's just like that. And it's allocating place memory to keep the information associated with that object. So every time we do that, we create another place in memory where we're going to keep specific information about each of the objects. So each one will have a different variable name, and we're creating a similar thing in memory. So does that kind of make sense? So let's look at the next assignment. What are we on? So we're looking at P7 coming up next. So last program we're working on is really making a program with three functions, right? One that gets user input, or one that displays a header, one that gets user input to get a point. You get a tuple with a latitude and longitude. You call that twice, so you get two latitude and longitudes. You pass that to a distance function. Use the Haversine formula to display distance. This program is basically to make a class to do the same thing. So we're going to get to reuse some of this stuff. There's going to be some differences, so you won't be able to just take the methods and throw them into the class and call it good. You're going to have to do a little bit of modification. But you're going to make an init. You're going to make a geopoint class that has the following. It's going to have an init method that is going to set two attribute variables, self.lat and self.lon, and probably initialize them to maybe zeros. That would probably be a logical thing to initialize them to. And then you'll also have self.description, which you'll initialize to an empty string. And then you're going to make a set and get point method. And the set point method is going to take, in addition to self, it'll have latitude, lat, and long, and it's just going to set self.lat equal to lat and self.lon equal to lon. And then get point will just return a tuple with self.lat, self.lon. Now realize this is not get from the user. This is get from the class. There's no input in here. This is just saying return self.lat, self.lon. You're still going to need that input function that you had before to get stuff from the user. But that's not part of this class. And then you're going to have a set description and get description. And they're going to, the set description, you pass in a string and you'll set it into self.description, and get description will just return self.description. And then you're going to make a distance method. And this is basically going to be very similar to your current distance method, except that you're going to pass in a latitude and longitude, and this method is going to figure out the distance from self.lat and self.lon to this lat and lon. Does that make sense? So this lat and lon is not self.lat, self.lon. That's another point somewhere else. This class will already have a self.lat and self.lon, and so your calculation will be between so it'll be something like this. It would be this, so lat1 will actually equal self.lat. Lon1 will equal self.lon. And then lat2 will equal lat. And lon2 will equal lon. And basically this lat will be going into here, and this lon will be lon2. So if we're using lat1, lon1, lat2, lon2 in your calculation for your distance function, this is now the first point, and this is now the second point within this distance function. Because we're going to use set point to set the lat and long into this class, and then the distance would be from itself to whatever you passed in. Does that make sense online? You may need to get into it a little bit before it starts making sense. And this is one of the harder things to get set up, so I'm kind of expecting people to send me, their code and ask me to kind of give some inputs and stuff. And so, so what will then happen then is inside of main, you're going to instantiate 2 points using this geopoint class. And then you're going to use the set point and set descriptions to set the lat and long for these points from whatever you want. You just hard code that in. So for example, you could pick the latitude and longitude of Santa Fe and the latitude and longitude of Albuquerque, and point 1, you'll do point 1 dot set point, latitude and longitude of Albuquerque, point 2 dot set point, latitude and longitude of Santa Fe. And you'll just put those numbers in specifically. So now you've got these 2 geopoints, they've got a location set in them, and then you're going to make a do another loop, and you're going to ask the user for their latitude and longitude. And then what you're going to do is you're going to use point 1 and point 2's distance method to find the distance to point 1 and to point 2 from that user. So if you, let's say you got the user's latitude and longitude into the variables lat and long, you would pass the same one to point 1's distance function and to point 2's distance function. And then what you're going to do is you're going to use an if statement to tell them which one they're closest to. What's the criteria for which one they're closest to? What's that? What's the criteria you use to figure out which one the user is closest to? Yeah, so if distance 1 or less than, if distance 1 is less than distance 2, you could say you are closest to point 1 dot description, or point 1 dot get description. Else, you are closest to point 2 dot get description. And then you'll ask them if they want another one. Where this is leading is eventually, we're just going to do it with 2 points. Eventually, we're going to keep expanding this, and we're going to have a collection of points that we're going to get from a file. And then we're going to be able to use and then we'll be able to run through all those points in the file and find the point that the person's closest to. An analogy would be, let's say we're in an airplane and the pilot goes unconscious, and we're programming this airplane to automatically divert and go to the nearest airport. And it's got a list of airports. It would go and look at its current GPS location, pass the lat and long to that list of points, find the closest one, and then turn and fly towards that location. And then, maybe one day they'll have the ability to just have a pilot remote in the secured system and land that airplane, or have the ability for the airplane to communicate automatically to tower and say, hey, I'm coming in, clear the area, and say go when you want me to land. But for now, all we're doing is we're making a class to represent a geopoint, and you pass in a latitude and longitude, and it figures out its distance to that latitude and longitude. Does that make sense online? Does that make sense to you all? Yeah. So that's the next assignment. The rest of this is lab time. So let me know if you have any questions on anything, both online and here.